Okay, are we live? We aren't live yet. Why aren't we live? We are live. We are live and streaming. Okay. Why aren't we live? We are live. We are live and streaming. Okay. Okay, we're live. So let me just share this quickly with our social media folks so everyone can join the stream today. So I'm going to um, share the live on LinkedIn, just I'm showing you on the screen. And in theory, we're all set up. Just let me quickly check day five. Okay, it's not day five. Today is day number six. I'm building MINA. So let me correct this. Okay, you shouldn't see that. So let me move this to the other tab, and yep, I guess we're good to go. Um, Let me first just check if audio sounds okay, because we don't want it to be like the first stream where audio was problematic. Where audio was okay, so as I'm seeing here, we're okay with audio, so I shouldn't worry about that. Now let us start. Let us start with today's stream. What is it about? What are we going to do? What did we do last stream? Don't remember. I do remember what we did last stream. We did a lot of learning. Last stream was one of the biggest stream we've made. We've made like a 3 hour stream from like 6 p.m. to 9 p.m. something like that. So let's start. Okay, let us begin. Um, Today's stream. What we're gonna do. So we already learned about LangChain. We made quite some research. We dug deep into LangChain's documentation. So I mean, yeah, there you have it. In theory, we should know how to use basic functionality about LangChain. We're not experts in LangChain, but today we're going to determine if LangChain is the agentic tool we're going to use. Is if LangChain is the like the building block behind Mina, or will be like the building block behind Mina. So let me get started and try to set up LangChain on my machine. Okay, so I have here my Git repository. Let me open our let me open here our main file v.main.py. Okay, so this is our main file, and what we're gonna do is what we're trying to first we're going to try and set up an agentic AI. But first we need to set up our local LLM. So we need to set up our local LLM by setting up we need to set up our local LLM by first determining what local LLM is available as a launching integration, download it, and see what happens. Okay, so I remember there was some kind of documentation on the available models. My camera just dropped. Doesn't matter. It's fixed. So, okay. Okay. Let us see. Okay, so um, we have a variety of models. Mhm. Okay, so uh, let us do this quickly, and instead of researching through this, let's just ask GPT what are all like the available LLM integrations for local LLM models in LangChain. So let's ask this guy like what are the available uh, local LLM models in LangChain integrations. So let us ask this guy. Okay, so what is there? Okay, here's a breakdown of the local. Okay, so we have several. We have Llama, CPP, GPT-4o, GGUF. Okay, no, okay. We've got TextGen, Transformers, Hugging Face, Olama, MLC LLM, which I don't know about, VLLM, AutoGPTQ, and C Transformers. Uh, okay, okay. Um, anyways, let's determine what or which is the local LLM that we're going to use. So my first thought was to use Llama CPP because I've heard that all Llama models or Llama models like these models from MINA are like well supported and are like actually pre-used for everything that has to do like local LLM development. So I see a potential there. I also see that we have GPT-4o, which I'm guessing is a kind of like like LLM model from OpenAI, but I'm not really sure. Okay, then you have other models, but again, what we need is whichever is like has the most multimodal capabilities, and that's it. Like we need only like multimodal capabilities for the final product. But since this is like a POC MVP kind of first draft, we'll need like text capable, like a text only capable LLM model or model. Okay, so there are also other open source models, mm, but I guess okay. I think what do you need to choose on? Okay, so interestingly enough, GPT told us here what we should do or how should we choose one, which makes sense. Again, uh, it's based on resources, so if it's CPU only or GPU available, I'm using an NVIDIA GTX card, 1660 Ti. So I guess I should take leverage of GPU, although it's not the really potential. It's not like the most powerful GPU. It would make sense to take advantage of my GPU. Uh, and now that I'm thinking about it, I think for like for future for a future, let's say, release of Mina, it would be nice to have optional or to be able to opt in or opt out of GPU enhanced models. So maybe you could configure like what LLM model you want to use, or it could be determined like automatically on install depending on your hardware. But again, since this is a first draft and we need it to run on my local machine first, let's see how a GPU enhanced model works. Okay, so do you want speed or small memory footprint? Um, again, uh, a type of operations that Mina is going to handle, meaning having like real-time requests via voice activation requires speed because we don't want like high levels of latency. So again, probably we should aim for more memory friendly and speed friendly LLM. Okay, so yep. Then are you planning to use LangChain agents or simple Q&A? If you tell me okay, so let's take leverage of GPT and provide enough context so he can give us like a best recommendation for our model. So if you can tell me, okay, more specs, okay. So I'm gonna tell this guy about my machine. I have my machine has 32 gigabytes of RAM in my case. I think in the future we should choose like an LLM model like based like a base LLM model to have like some base requirements for the model because again we don't want to use like the highest performance LLM model that requires the most resources because again we the idea is to launch Mina so anybody or most people with a decently enough computer can run Mina. So yep, I'm just gonna give my specs because again, first draft POC MVP, so that's the thing. By the way, I've been saying that this is an MVP POC first draft, whatever, and some of you guys probably don't know because this is vocabulary more on like the software development life cycles on the SDLC. So let's say like a first draft, it's like some kind of beta. It's not kind of beta because we're not going to release this, but like a POC, it means proof of concept. It means like a version of a project you do uh, when you're trying to discover if like your product or your software is like has some value. So that's or some or the concept itself makes sense. So you would also call it like proof of value or proof of concept. So this is like a proof of value or an MVP. Also, you people well it's technically different, but an MVP is like minimum viable product, and it's like a version of a product or in this case software that you develop that is intended for end users as like the quickest and fastest way you can develop. So yep. So this is not it's less of an MVP because we're not this is not intended for end users. This is more of like a POV POC, like proof of value or proof of concept type of thing. So yeah, that's what we're doing. And that's why I'm asking GPT for a better recommendation of the an LLM model to choose based on my specs, on my computer specs, on my hardware. So my machine is 32 gigabytes of RAM. My CPU has 12, 12 processors, I guess, 12 cores, and GPU is a 1660 Ti with 4 VRAM, I guess. I don't remember my VRAM, so I'm not gonna look it up because I don't wanna leak any kind of software specs. I don't know if there's any sensitive information that I could leak if I check like my my software specs, like if I use some kind of C like command like lshw, I guess. I think lshw outputs. I don't. Okay, doesn't matter. I'm gonna show this on stream. So I'm gonna assume I'm not gonna provide like these uh, details. So again, CPU based. Okay, so Llama is CPU based. Okay, works well for chatbots, track systems, or agents. Okay, up to 7 billion models in a 4-bit 50 quantization. Okay. I also have GPU based. Okay. Olama is easy to install and runs optimized. Okay, in the background with GPU. You can connect LangChain to Olama with. Okay. So I could use Llama CVP or I could use Olama, which has uh, okay. So I'm curious about setting up Olama and Llama CPP. I don't know why, but I don't feel like trying to figure out like how to take leverage of my GPU is like a good idea for a first draft POV POC version of this. So let's just ask about Llama CPP and Olama. Okay, so provide guides on Llama CPP uh, and or Llama models. Because I'm curious to know more about the Llama integration here. Because if you read this like snippet of code, it shows how you use Olam this like Olama function to get like directly like your LLM model by providing only like the name of the model. And again, that's probably not what we want because we want to be able to manage like the physical GGUF or like the physical file of the model. So again, probably not ideal. Uh, Anyways, I'm not gonna judge about my cover and let me do some research on how this is done. Because I'm here, I'm throwing like my like assumptions and assumptions aren't like concrete ideas. So let's first check out this. Okay, so the first guide is to use Llama CPP, which is like this wrapper around Llama's Meta's Llama Python library, but in C++. So it should be more performant in theory, except it's not running like directly like C++ code, I think. Because since we're using Python for our POV POC first draft, I'm gonna start calling it POV POC because easier since easier than saying first draft POV POC POC. So let's just call it POC proof of concept, which is what we're doing right now. Uh, okay, so yes, so since we're doing Python for this POC, probably not running any kind of C++ code directly. But I guess what we are running is like some kind of C++ backend server that runs like all these models, like as a model loader, cause that's what I read on our previous prompt from our previous prompt. But let's just read first. So Llama CPP was recommended for full offline control, which is what we're looking for. We want a local LLM model that we can control completely without depending on API services or third-party cloud providers like uh, Azure OpenAI or Claude's. I don't remember who manages Claude. I think it was who manages Claude. Claude AI, which is like another big LLM. Claude is managed by Anthropic. Yeah, so we don't want to be managed or controlled or vendor locked by Anthropic, nor OpenAI, nor Azure OpenAI. So again, that's why we're using this local LLM model approach. Okay, so again, Llama models work with GGUF, which are like format for models, as we learned, which are like optimized for like an operating system, which is what we learned because you have like all the formats like that you can get from thinking or creating models using TensorFlow or PyTorch. But again, those are not like the most optimized versions of the models. So you get these optimized versions of the models, by transforming them into a GGF or a ONNX file. I'm gonna call it GOOF or ONX because it's easier. So these GOOF files or ONX files. So yep. Okay, so you install the Llama CPP Python wrapper, which, as we said, it's like a wrapper around another wrapper because you have like Llama, which is a Python library provided by Meta. Then you have Llama CPP, which is like not a Python wrapper, but a C++ version, which is like the optimized version of the Meta library. And then you have Llama CPP Python, which is like the wrapper around the optimized version. So okay, so it doesn't make much sense, I guess. I mean, there's like some uh, bidirectional issue here. Some, I don't know. Okay, it doesn't make much sense. But again, you install this Llama CPP Python library, then I can download the GGUF model. Okay, so this was my question, my big question I have. So yes, if I use Llama CPP or yes, the Llama CPP Python wrapper, I can run directly like files that I manage in my code base. So okay, so because I give it a path to the GGUF model. Okay, so interesting, and I have full control over Llama CPP or over the models because I can download them. I'm curious about what kind of models can I load using this Llama CPP loader, because I mean it's Llama CPP, Llama Meta. I mean I think I can't run like like my I'm guessing I can't run like custom models which are not like GGUF or like GOOF optimized or Meta models. So yes, I can use like Mistral, Llama 2 or Gemma, but wasn't Gemma like some kind of Google model? I'm guessing it is. Uh, yes, Gemma or Gamma open models. Okay, I didn't even do any research, just read the first link from the Google search. But yes, I'm going to assume this because don't want to get deep into Google open source models. And yes, this is simple to set up. You simply install AmaCPP, you install my local LM model, and then I call it from a LangChain wrapper. Okay, so again, LangChain, this like abstraction layer to interact with like LLMs. Pretty nice. Then I have the second option, which was using OLama, but I don't get what's OLama. I mean, what's the difference between loading OLama and like an all? What's the difference between loading a model with OLama and Llama CPP? Not sure. Okay, so it's easiest to set up, automatically optimized models, and runs as a background service. Okay, so it would require to run like a different component, or not a different component, but a different service. But again, this is a POC, and if it's the easiest to set up, and I wouldn't need to worry about all these temperature max tokens, verbose features, which are like like parameters that I would worry about if this was like a more serious like final application, let's say. So, since this is a POC again, I'm doing everything with POC in mind here. Think Olama would be a better choice. And then when implementing like the formal, like final, like not like a beta version or like an alpha version of MINA instead of a POC version, uh, would be a better idea to uh, simply use this or use the libraries that let us like optimize the most and customize the most. Runs as a background service, supports GPU by default. Nice. Uses your 1660 Ti if available. Okay, so I would need to install Olama, download and install. Okay, so I would need to install and download like the like the service by myself, but again, having to run Olama as a service doesn't make Mina uh, that of a single bundle. It would make Mina more of a service that depends on another service. You want to make it like okay. I'm not sure if I like the idea of this. Okay. Okay, and is there a way to install Olama in Gento? Because I don't want to install it from curl. Okay, I have an overlay in some kind of Bento, BGO. Okay, so I have a couple overlays, which are a couple of Gento repositories. So yes, portage overlays that have Olama. But again, I know this is a POC, and the idea is to try like the value or to check out the value of the tool or the concept of the tool to check out if it works. We can't or we shouldn't develop this POC like using like external or developing in a way that would be very different from the way we would develop it for our first non-POC version, let's say. So I could, in theory, okay, so the idea when using Olama is to run to run the model and then okay to run the model here to run the model like globally on my machine in my service and then simply call it or you use the Olama wrapper or the Olama integration simply by specifying the name of the model in the function call. Hmm, GPU support optional built-in LangChain ready. Yes, yes. Okay, so I think my we might go with okay, I want to ask GPT about two things. First, I want a comparison about these two like model loaders. I'm gonna call them model loaders because that's what they are, a way to load your models. Okay, so yeah, let me ask for a comparison about these two to get a clear idea, and then let me ask about sources to download models because I've heard about Hugging Face and I know you use like Hugging Face to download models or something with models or to host like models. It's like an LLM or not an LLM but like a model repository. So let me ask about it. Okay, so GGF. Okay, so please compare Olama and Llama CPP in detail. Then I'm going to ask this. Then I want to ask where can I, okay, I'm gonna, okay, okay. Let me give it enough context so it knows that I plan to use Olama. I want to use Llama CPP, but have a couple questions. Have a couple questions first. And okay, please compare Olama. Okay, where can I download local models to my machine? And I also want to know what is Hugging Face. Okay, so what is Hugging Face and how does it relate to open source models? Okay, I just received a message via WhatsApp, so let me just check this because it might be important. I know I'm streaming and I probably should focus on whatever this GPT just answered, but you never know. So, uh, okay, it's kind of important, so let me reply really quickly. So, my okay, now done with that. Let me read this. So you have Llama and Llama CPP, so ease of use. Okay, so Llama or Llama is very user friendly. It's one command to run models. The Llama CPP, it's for more manual, but again, you have more granular control, so that's what we're looking for. You have setup config and you have Python integration. You have installation. Uh, you would have to install like a package and build it versus simply install the installer here. Uh, okay, so interface runs local HTTP API server used by Python, Llama CPP, or native CPP. Okay, so what I'm seeing here is that when or if I decide to go with Python or not Python but Llama as my model loader, I'm gonna have to run on this service, which is an HTTP API server that exposes like not exposes but receives not receives but like get requests. So like the Llama integration module from acts like as a client to the server and gets requests. S- and that would not be very performance wise because that would add latency because you would be in theory you would have to be making like HTTP requests to the service that's on your own machine. But again, it's my own machine, so there's no it shouldn't be uh, there shouldn't be much latency because again, my lookback interface probably I'm doing the request to 000 to like a 0.0.0.0 address or like that my yeah I mean it's like my same address but again there is always some latency when you're trying to access the network because like the whole packet and the whole TCP fragment like the segment needs to be created and although it might sound like I'm getting like too specific uh, because it's like a request to my same machine, so it shouldn't make more in theory it shouldn't make it shouldn't produce much latency. But those like type of like very granular like issues or like processes are the ones that always add up, and in the future it might bottleneck like like the like the speed of MINA. So like the response time of MINA. So and it's interesting because I have some background on networking and computer networks. So this is like why like on my on studies I have like formal studies on computer networks. I really like knowing about how network works, and I do know how like the whole packet fragmentation, like the whole network layer works. So I know that making a request in mass, it can be like quite consuming or resource consuming. Yes, resource consuming. Resource consuming. I think that's not how you said it. But the thing is that what I'm trying to say is that uh, like high volume of network requests are always they always consume resources, and we would have to be making well, it could be possible to make like a high volume, or maybe not high volume but really uh, big requests with a lot of bytes, because what if the LLM model returns a lot of tokens? So again, the request, it's big, the TCP window needs to change, to expand, to get more data, the whole TCP. Okay, so the whole process again. So this is, I think we're not. Yeah, so you have like the 7 layers of ISO. So we're not talking that we're not like going through the ax to the physical nor the access layer, but we're going through the physical, not the physical, but like the IP network layer and the TCP layer and the three application layers, like the session presentation and and the other one. So again, data is passing through all these layers just to interact with with I mean, just to get some information that easily could be on the same on the same memory space. So yes, not much performance would be leveraged from that approach. So I don't like the idea of using HTTP like Olama as our model loader. Again, that's a reason why we probably, or like I wouldn't probably advocate to building Mina as modular as going to like a microservices approach, or like if we need to, for some reason we need to develop like in like a multilingual code base. I wouldn't advocate to using some kind of RPC or network-based communication between languages. I would probably advocate for uh, language or like a binary level communication. But network is like heavy, so that's a no-go for me. Anyways, let's continue reading. So, Olama Lama will support goofy files. I'm gonna call it goofy files, like your gguf goof. Okay, goof files, same as llama cpp but managed. Okay, llama cpp, you manage my goof files, which has some advantages to it. Okay, so yeah, anyways, okay, so you have this model support and okay, hardware support. Olama uses GPU by default, uses Metal on Mac, CUDA, and OpenCL on Windows and Linux. Okay, so it would be nice to take advantage of CUDA, but again, I does it automatically. I can't configure that. And if we're gonna deploy MINA to various, because the idea is to deploy MINA to a lot of like native or a lot of platforms. it would be ideal to configure or support as much platforms and operating systems as we could. So we should make it possible to configure Mina or to set up Mina on download or on install depending on your hardware, which you mostly do on code. And as I see, it would be possible to do it via the Llama CPP Python library interface. So, and you wouldn't be able to do it with like running like the server, or maybe you could do it like running, like you could configure like the Olama server to do it. But again, you would have to configure it, the service, the Olama service instead of your code. So, probably no go. Then custom control limited to CLI options. Again, just what I just said. There is less tuning opportunity. Then you have Llama CPP, which you have full control over GPU layers, batch size, and number of contexts. Model management. Okay, so again, multi-model support. Switch models with one command. You control loading in your code. Okay, so offline mode. Yes, after pulling modes. Fully offline from start. Then you have LangChain integration. Supported. Both have like LangChain to a Python native control. No, okay, so again, the REST API is a killer for me. I really dislike having to call a REST API, like having to make a network request to my own machine just to get some data. It sounds like really like a bad idea because again, it might these requests might be like really large if they like return like a big number of tokens. So no, yep, no, don't like it. Okay. So TLDR or Llama best for quick start of simple CLI or API workflows, and Llama CPP based for Python native, fine control, and advanced chains or agents. So where can I download? Give me a sec, guys. Oh, okay, I think I'm getting sleepy because I just yawned. It's a shame because we're only 40 minutes into the stream and I have a lot of curiosity and I don't think I will have enough energy nor time to do whatever or all that I want to do today. That's why we're doing streams most days of the week, not all days of the week, and not weekends definitely, but on the week I'm trying to do like three or max, like three max four, because I do have other things I need to do during the week. So yeah, that's what we're not like doing like a straight up like 8 hour stream because I do I have a job, but it would be nice to dedicate like Mina as like a full job, like 8 hours or more, like a shift, literally like working in Mina. So yeah. So how to download local models GGUF again? You know, before I proceed, this is some kind of learning experience also. So um, you know, it's some kind of so that's what so, yeah, so this is some kind of learning experience, so we're moving slow or slower than we would if we or I knew everything about this new problem space that I'm approaching, which is agentic AI, so this type of AI technology. But again, that's like the fun in it, that's like the joke, like learning. So yeah, this kind of learning stream, learning while doing, because we're learning with and only probably not only the goal of, but mostly with the goal of building Mina. So it says where to download models, so I can the most quality goof models are hosted on Hugging Face. Okay, so it's an account that converts open source models into GOOF formats compatible with Llama CPP. So steps is to pick a model, like the block Mistral B GUF. Choose a file like GGF, click download, or use wget or Hugging Face Hub Python package to download via script. Okay, so it says use G4KM quantization for balance, speed, and quality. So again, it says what is Hugging Face because it just mentioned about where to download models, like download them on Hugging Face. But what is Hugging Face? Okay, so Hugging Face is a platform and community for AI and ML researchers and developers. Interesting. Hosts pre-trained models, datasets, demos, and libraries, and known for popular Transformers library, which as I remember, the Transformers library is like a loader for LLM models, so it would be analogous to these other LLM loaders that we're comparing here. It says open source and Hugging Face. Most open source LLM models are published on Hugging Face. Okay, so Meta, Stability AI, and Google, these research labs publish stuff in Hugging Face, and Hugging Face acts like GitHub for ML models, central repo tool to download and use them. How it all connects. So Hugging Face is where I find and download the models. Llama CPP is a backend engine or a model loader, which is a concept we learned a couple days ago, some days ago. And LangChain is an Olama that connects LLM model memories, tools, and agents. And Olama is like an optional abstraction over Llama CPP. Okay, so let me visit Hugging Face because I'm curious about what Hugging Face has or what kind of models are even downloaded here. So the AI community for building a future platform to learn machine learning models, datasets, and applications. So there are okay, so interesting that they have datasets. And I think this we could use some kind of okay, any we could use datasets from this like open source GitHub kind of Hugging Face platform if we ever need to create our local or not our local but our kind of LLM model, not LLM model but model, yeah, like plain raw model. We need to create some kind of model. We could use some kind of training data set here. There's also like applications, which I guess like AI people who want to showcase what they're doing. Host here application, and then you have like a million models. Okay, so there is a million models. Could I filter by GGU, by format? Okay, are they all multimodal? No, they aren't all multimodal. But again, ooh, interesting. I think I'm gonna become a fan of Hugging Face. It says, the collaboration platform hosts and collaborate unlimited public models, datasets, and applications. Okay, build your portfolio, accelerate your ML, and how do they make money? Okay, because this seems like really nice, and there's a lot of community. But again, so there's an enterprise version of Hugging Face. Makes sense because they need to get money from somewhere. So 20 bucks per month with your hub organization. Nah, nah, not interested. Not interested either. Okay, so now we know where we can get our bots, and I think we're gonna our bots cement our models. So let us llama see uh, where's the okay, so you have Chateau Llama. Okay, you have Chat Llama CPP. What is this? What is this? And where is okay, so we determined what we're gonna do, what models we're gonna use, what loader we're gonna use. Okay, so okay, no, we didn't determine what model we're gonna use. Let me ask GPT-4 for any recommendations. Okay, what model would you recommend to load using llama CPP? Okay, so I have part of you've got enough power for 7 billion parameter models. Okay, especially in quantized formats. Here are my top recommendation based on speed, accuracy, and compatibility with Llama CPP GGUF models. Best all-round chat models. So you have Mistral, which is open source. It's MIT. Again, it adheres with MINA's open source license because it's also MIT licensed. Okay, it's number two. Uh, it recommends Tiny Llama. It's faster and smaller. Performance for reasoning, instruction, and code. Technical. Then you have Open Hermes for coding and agents. Okay. What does K4KM mean? Or Q4KM mean? It's quantization level or compression format used by Llama. You have like okay, so the fastest ones use the least RAM, but has the poorest quality. Then you have the slowest ones, which has the highest time usage but the best quality. So for your setup, it recommending this. So a balance between great quality, medium speed, and medium RAM usage. Okay, so let me tell this guy that I'm trying to create an agent. Maybe it can do some kind of recommendation based on that, because is an agent because okay, an agent requires speed because of like the multi-tool conversation nature of an agent. But let me ask it. I'm building an agent with what model? Let me tell it that like what model should I use? I was gonna tell GPT about like what type of model, what type of agent is it like if it's like a conversation based, like a user, like I remember it had a name. This we read about it in Google's article on the first or second stream. So let me just remember here. a single agent, an interactive partner. Yeah, that's how you call them, interactive partners. So, okay, so you need instruction following, multi-turn reasoning, tools and function calling plus RAG. So, top choices Open Hermes, Mistral 7B. It's number two on Open Hermes. It recommended Mistral 7B previously, but again, this is best for reasoning instructions. But if it's best for reasoning, that means that it probably takes more time because of this like K4 or let's say quantization level or quantization table here. It recommends so it finally recommends using OpenRMS 2 Mistral 7B built on Mistral, which is again like a base model. It's fine-tuned for code dialog and Open Orca, which I don't know what is it, and it's excellent on following instructions, handling tools, and reasoning over by multiple steps. LangChain based agents on okay. Number two, it recommended Nor Hermes to Mistral V, and number three, another one which I'm not even sure how to pronounce. Okay, so it recommended this agent. So let me check how to download like an agent using this guy. Let me just also ask about quantization and quantization because I'm not sure what does that mean. And I do really want to learn about this. But wait, why can't I just open this link? Why is it like not letting me open this link? Okay, so I'm gonna keep this here while I ask what is quantization. Quantization. What is quantization? Quantization. So it says it's a key concept when working with local LM models like Llama CPP, especially when you want models to run efficiently, unlimited hardware like your GPU, CPU plus my GTX Ti. So quantization in LLMs is the process of reducing the precision of a model weights to make it smaller in size, faster to run, and use less memory. Okay, so quantization it's like optimization. Full precision model might store weights as 32-bit floats, which is crazy. 32-bit floats, 32 bits, that's like 4 bytes, like 4 bytes, like allocating like a weight like in 4 bytes, like 4 bytes is crazy when you have like millions or of, I don't know, like a ton of weights. So that's crazy. Probably want to reduce it to a quantity of my story in a 4-bit integer. Okay, it's half a byte. So you can okay, so half a byte it's like really tiny, really small. You can't even like store most ASCII characters in it because ASCII is like 7-bit like system. So instead of using 32 per byte, you're using only 4 to 8 bits. Okay, why is quantization important? So quantization, how would you define it? Is a process of reducing the precision of model weights to make it. Okay, that's the so quantization. You reduce the precision of model weights. You make the model weight smaller for optimization purposes. Faster to run, less memory, smaller size. Okay. Then, why is quantization important? A 7B model can be 3 to 5 gigabytes versus 13 to 30 full precision. No need for big VRAM or long startup times. Or more storage CPU if needed. Less resource use. Okay. Types of quantization. But what is a 7B model? Like a 7 billion parameters? Does quantization harm the model? Some accuracy is lost, but well quantized models like Q4KM still perform amazingly well. The trade-offs offer, I mean, what quantization level is this recommended model? Okay, so I have, okay, so there Q4KS, so the Q4, Q4, so the recommended one was Q4KM. Okay, so we have Q2K, which is experimental, good balance. Okay, it's the Q4O, but Q4KM is best for agents or most setups. Q5KM, it's for agents, a little bit slower, but again, better responses. And the Q80, it's close to original quality, but again, it's like 4 times smaller. Because again, Q8, it's like using 8 bits. Again, a byte versus 32 byte, a bit. I mean, 8 bit, 8 bits, 1 bit. No, 8 bits, 1 byte versus 4 bits, 32 bytes. It's like a 4 time difference. So yeah, I guess, man, I don't guess, but I assume it makes sense. I think it makes sense. I strongly think it makes sense. So yeah, it's everything. As always in computing, it's everything about trade-offs. So you're trading off time and by memory usage. So where to find quantitative models? So let me probably a K4KS. Yeah, I'm probably gonna use the K4KM one, which is 4 gigs. The blog, interesting account. Okay, not interesting, but a useful account. I mean, who in the world takes the time to have all these models here? What a nice guy, really. Quantization. So let me ask, what is this 7B model? What is a 7B model? I don't know what that means. Uh, what? Uh, what? Okay. So what is a 7B model? It's a short form for language model with 7 billion parameters. So what are parameters? Parameters are the, I think parameters are the weights, are the internal numbers like weights and biases that the model learns during training. Okay, so yeah, makes sense. Like, so parameters is like the weights. These numbers are used to generate predictions, answers, or text. In an NLM, these parameters determine how well the model understands and generates. So 7B, 30B, and 65 billion parameters. Yeesh. So a 7 billion model has 7 billion learnable numbers. Why does that matter? So more parameters means potentially smarter model, but again, slower, bigger, needs more RAM and VRAM. So Tiny Llama, it's a 1 billion model, which is a lightweight model, but lightweight, not, but lightweight testing mobile. Okay, you have Mistral 7B, which is the one we're using. OpenRMS 2 Mistral 7 billion model, which is high performance, fast, and compact enough. Then you have Llama 2, which in Llama 2 with instead of 13, 65 billion parameters, which the 61 is like a top tier quality, but huge. Yes, I'm guessing that's like really, really huge. like 30 gigs probably. 7B is perfect, especially in quantized format. Again, uh, okay, so an hour and 5 minutes have passed. It's 9:40. Today we haven't done much practical things. I was expecting to get my hands more dirty today, like doing more hands-on stuff. But again, this is learning process along with like it's a project that I'm using to go in hand with some kind of learning. So yeah, interestingly enough, we learned stuff, we learned new stuff. We reinforced some learnings. Again, um, I really want to continue. I really want to continue today. I'm tired and I probably should get some sleep. Again, probably tomorrow when I do another stream. I prefer doing like short, consistent streams instead of like long streams once a week. Because I guess I think like like theory and concepts are kept more in my mind if I constantly feed them information with it. And I always say that consistency is best. It wins over like a sudden or it's like a sudden spark or not like sudden spark but like a sudden stream of 3 4 hours done like once a week or twice a week. So again, let's continue tomorrow with another quick with another quick stream. We'll continue figuring out how to set up our Open Hermes 2 Mistral 7B Goof model. What a long name. Let's just call it like a Mistral model. Tomorrow I want to set it up. I already know how to set it. Well, not how to, but I already know what to set up, why I'm going to set it up, uh, specific reasons, like technical reasons about why we're using, so it makes sense. Yep. So I think it makes sense, and I think I'm making the right decision with the help of GPT. Or of course, again, just need to re-say this. GPT is my research friend, like my research companion, or like my research peer. So we're gonna be using GPT or whatever if I ever want to migrate to DeepSeek or Claude or whatever other LLM model. But again, yes, we're gonna use these LLM models as a research tool through the whole process probably because it's easier and etc. But again, that's everything for today. Tomorrow, expect another short stream, probably hour and a half, when we're gonna try to set up this Hermes thing and not Hermes but this Mistral model to set up our final agentic model and have our agentic or agentic AI model or agentic AI tool or agentic AI application called MINA. So let me say goodbye for today. Goodbye. Bye bye. Buenas noches. Ciao. Good night. Uh, I don't know any other I do know others, but I'm not gonna say like any other ciao or adios in another language. Ciao. Bye.